So hi everyone, we're going to go over a little bit of Newton's laws and force and talk about everything you need to know for Module 5. So to sum it up, we know that Newton's first law tells us that if a body's at rest, it will stay at rest, and if a body is in motion, it'll stay in motion unless acted on by another force. So that's known as inertia. And we know that Newton's second law can be summed up by the sum of all the forces acting on an object equals its mass times its acceleration. And we talk about the sum of all the forces acting on it being an acceleration. We can use Newton's second law to also determine specific forces that are acting on an object, like the force of gravity. So the force of gravity is going to equal the mass of the object accelerating at the acceleration of the planets. Whatever planets it's on, the acceleration of gravity is going to determine that. So if we're on the Earth, it's going to be accelerating at 9.81 meters per second squared. So, and Newton's third law tells us that for every force that we have, two things that interact will have an equal and opposite force. So if I apply a force to this whiteboard, the whiteboard is applying the same force back to me. So those forces are equal and opposite. So when we deal with Newton's law problems and formulas that we need to know, we're always going to start with an object. So we'll draw our square to indicate our object. Any kind of object that we have, we're going to use our square for it. And we're going to try to identify all the forces acting on it. And so we know that the force of gravity, for our purposes right now, is always going to be acting down. And we know that the force of gravity is always equal to the mass of the object times the acceleration of gravity. And as long as we're on Earth, the gravity is 9.81 meters per second squared, and the mass of the object is always going to be in kilograms, and that'll do our force. We also know another force that acts on an object is the normal force. So if an object is not moving, or it's not moving side to side or whatever, we know that it's sitting on the ground, it's not floating off into space, and it's not plummeting through the earth toward the core. We know that the normal force is going to be equal and opposite the force of gravity. So if we have a number for the force of gravity, we can say that the normal force is going to be that same number. And we'll look at a problem in a minute. The other forces that can be applied or that act on an object is the force applied. So if somebody's pushing on it or pulling an object, that's the force applied. And the force that opposes that force applied is the force of friction. And when we worked in our labs this week, we learned that the force of friction can either be static or the force of friction can be kinetic. So if it's static, that means the object is still, it's not moving, and the kinetic force means that the object is in motion, or it is moving. And so those things are, the force of friction static or the force of friction kinetic mean the same thing as the force of friction. And we talked about how in the book that he uses just a lowercase f, we're going to identify all our forces with a capital F, and then the lowercase to identify which type of force they are. So the formulas that we need for Module 5 are the sum of the forces equals mass times acceleration. This means that we're going to add all the four forces acting on an object. And for example, it's this one. It would be, we look at them in pairs. So the force of gravity plus the normal force. The normal force, I'm going to put a negative sign on there because it's going to be in the opposite direction. So we're talking about it being opposite the force of gravity, so we'll have a negative sign there. And we're going to continue to add the force applied plus the force going in the opposite direction, so the negative of the force of friction. So we can find all of our individual forces if we know some of them or the sum of them, if that makes sense. The other formula we have, of course, is our force of gravity, which is mass times the acceleration of gravity. When we're talking about this one, it's always 9.8, and when we talk about this one, it's usually something that's not 9.81 meters per second squared. So if we have an acceleration that's not 9.81 meters per second squared, we know that we're looking for the sum of all the forces added together.